Please pause this video if you have not tried the problem. If you have done the problem, then go ahead and watch and see how this is done. So we want to find the relative extrema of the following function. F of x is equal to -1/2 x to the 4th minus x to the 3rd plus 2x squared plus 4x minus 2. I have graphed this function. You can see the behavior of the function here. So let's look for relative minimums and relative maximums visually. The relative maximums are going to be the highest points around. So you're going to find those on the tops of hills. So you're going to look at this hill here that looks like about x value of -2. And you're going to look at this hill here, which looks a little bit more than 1, maybe a 1.3 or 1.25. Those 2 points are going to be points where there are relative maximums, because this point here, let's figure out what it actually is. 1.281, 2.957. That point is bigger than all of the other points around it. So in its local region here. The same is true for the point -2, -2. It's larger than all of the points around it. When I say around it, I mean just in its local area. So if I drew a small circle around that point, it would be the highest one. Notice a point like 0.431, 0 is neither a minimum nor a maximum, because if you draw a little circle around it, you're going to get points that are taller and points that are shorter. So that's what you should think of. If you draw a little bit of circle around it, is it the highest point in that circle? -2, -2 is such a point. 1.281, 2.957 is also such a point. So both of these are relative maximums. By the way, obviously one of them is a larger relative maximum than the other. But they're both at the tops of hills, so they're both relative maximums. In terms of relative minimums, we only have one point that's at the bottom of a valley. That point is -0.781, comma, -3.614. Again, bottom of the valley. Notice there's no other points that are sort of at the bottom of the valley. If I try to draw around the point 0, -2, there are points on my graph which are bigger and smaller in its general vicinity. Obviously, a relative minimum here, it is a smallest around its area, but there are smaller points. There are points that are lower down in Y values. So this is a relative minimum, but it's not what we call a universal minimum. So that's how you can use graphs to find these relative maximums and relative minimums. Once again, we see the downfall is, that's a really hard point to see on a graph unless you have a Desmos system or unless you have a calculator which can do really precise graphing, which our TI-84s can do pretty precise graphing. So we're going to move on and see how we can use derivatives to find these relative minimums and relative maximums.